Welcome to day 7 of our class. In this day, we are going to explain more of our statistical analysis. At the same time, we are going to explore other statistical analysis options that we have. Thank you for joining the call today. And I really appreciate you for your tenacity and for always being available in class. This day 7 is going to see us explain all we have in our inferential statistics that we have done with regression and ANOVA. We're going to see how we can actually find and explain what we have in that particular table. Now, we are going to explain all the values we have in this particular table to see the fits and how they all relate to each other. First, in the regression table, we have the regression and the residual. Now, we also have on the column axis the DF, SS, mean square, that's MS, and then the F. So one might ask, what are all these things and what do they do? Well, the DF is the degree of freedom. And this degree of freedom is associated with the variability of freedom one has in estimating a parameter. The degrees of freedom are related to the sample size and determine the shape. I explained that got n minus 1 and of n minus n. Trying to explain the fact happening since we are using the graph as XLR, our parameter is just 2, which is hours of study and exam score. As n equal to 2, y big N equal to 2 and n equal to 2. That's what we are trying to explain. What's the difference? N to 2 is 20. All right. So the n is sample, and in our regression we have 2 parameters of choice: hours of study and exam score. That's our 2 parameters of choice. That's why it's small n. Sorry about the network issue that is throwing it on up and on, but we still battle it out. So for degrees of freedom, we are saying that it is a variability, a measure of variability that a particular individual has in choosing a parameter. This particular analysis we are dealing with is assumed to follow the normal distribution. Right? So every analysis we are running in statistics is assumed to follow a normal distribution. And this is how a normal distribution looks like. Allow me to draw it for us to see. So this is a straight line, and it's followed which is a level of significance, right? So it's assumed that this follows a normal distribution, which is what every analysis of choice we are working with actually does as well. So since our n, which is the sample in quotes or parameters or columns, is 2, while the number of rows we have is 20, is represented with small n and capital N. So for the regression now, it's simply a regression with just one parameter each for dependent and independent variable. Therefore, when we must subtract 1 minus 2, it gives us 1. That's the degree of freedom over here. Then when we subtract 20 minus 2, we have 18. So when we sum 18 plus 1, we get the total, which is 19. That is how we get the degree of freedom for the regression and the residual. Then for sum of squares, we said that for us to get the sum of squares, we need to actually run some mathematical expressions that we do by hand. And those sum of squares is what mathematically is already in your readings. So I will indulge you to go to your readings to see the sum of squares that has already been in for you to harness. And that sum of squares, you are not actually meant to know the formula offhand. Panic, all right? No reason to panic if you don't need it offhand. The main thing is that you understand what it does. So this sums the squares of everything. Now, what it means is that we get 15. So the way it works is when we get 15, we square it. Let's say 15 minus the mean, something like that. 15 minus the mean of the age, that's 12. So 15 minus 12, we now sum it raised to power 2, right? Sorry about the network. MTN is not stable, Airtel is not stable. What we want to do now, we have to battle it off. All right, so we are trying to see how this is calculated, the sum of squares, right? So you say 15 raised to power 2 minus 12, kind of. Then add it again, 10 raised to power 2, 10 raised to power 2 minus 12, which is the mean. So that's basically how Excel calculates this. So sum of each of these squares, this square plus 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 this square. So let me come over here. So this would be this square plus 10 square. Then 10 square plus dot dot dot. So this is what Excel does for you. Instead of you to do the mathematics yourself, Excel does this for you. 15 raised to power 2 plus 30 raised to power 2 plus 18 raised to power 2 down to 12 raised to power 2 and 15 raised to power 2 give you a sum of square, right? Sum of square. Okay. Then the mean sum of square will now be the sum of square you've gotten divided by the degree of freedom of the regression. Use the mean sum of square. Write the F, which is critical value, like we were saying, or F text, F calculated, as the case may be, some test. Will now be this mean sum of squares divided by this, we give you this. While the significance F is what is called F tabulated, or the p-value of this particular ANOVA, or the significance of it. And we said that because it is less than 0.05, that means our test is significance, and thereby we can reject the null hypothesis and conclude that the hours of study is affecting the exam scores of the students in question. Then we'll come down to the coefficients table. Notice that we have the t statistics and the p-value as well. We also have the lower and the upper confidence interval. All these parameters helps us to understand what happens in our data set. But this is just for regression analysis. And the in-depth of it is what a lot of us in the data science space uses for our analysis purposes. But we are teaching you this because you as a data science analyst will need to know how to use statistical analysis in your results. Let's go over to the next statistical analysis we have in our table, and that is the descriptive statistics. Descriptive statistics is another important part of statistics, which is just the same with what we have over here as part of the most important statistics that we always come to think about. If you have read your readings on the key statistical methods we have in data analysis, you will see a comprehensive reference on the key statistical methods such as probability theorem, permutation and combination, estimation, set theorem, chi-square test, one-way ANOVA, two-way ANOVA. What we have here already from the ANOVA table is a one-way ANOVA, right? Simple linear regression, which we have done too, multiple linear regression, sampling methods, logistics regression, ordinary regression, multinomial regression, and so on and so forth. So all these are the type of statistical analysis that we can run in any analysis project that comes our way, and it helps us to become better at what we do. Now, one of the reasons why we always see ANOVA come up for us whenever we do regression analysis, because ANOVA is the senior brother to regression, and in ANOVA runs what is called the F test, which is what we see here over as the case may be. And this F test is telling us the variance comparison of every value we have in our regression coefficients. That's why we always see ANOVA come with regression, because they all come together, right? From ANOVA, whether simple or geometric or not ordinary, we then get one-way ANOVA, two-way ANOVA, and the rest of them. Now, this helps us to understand how our regression varies in comparison with each other. Then we know that the t-test is there, like we saw there. This is t-statistic. This shows us the sample of the variance which we don't know that occurs in our data set. Now remember, we said that you're not meant to have this all jam-packed on your head. That's why you have directed you to the readings of this course, which will help you to understand what you are dealing with. Now let's come down to the descriptive statistics. We have showed us how we can actually prepare and set up our Excel sheet for analysis, and I believe that all of us have done so. For us to perform descriptive statistics, we are going to only work on that regarding the numerical data sets we have. And those are the age, hours of study, and the exam score. What are the descriptive statistics? These are the summary statistics that tells you some of the basic knowledge you need to know about your data set. How does that happen? It contains the mean, contains the mode, contains the standard deviation, the variance, standard error, the cutoffs and skewness, etc., etc. Now let's see how we can apply descriptive statistics in this particular data set we have over here. We are going to go to our data tab, then jump onto the analysis toolpack, which is just over here. And we are choosing the descriptive statistics, which is just over here. As you can see, this is descriptive statistics, as we can see. All right. So please, we are going to be clicking on OK. And you're going to choose our input range for this particular data. Now you notice that this is just the kind of thing that we will see whenever we are working with this statistics in Excel. For now, you are dealing with descriptives. So we are going to input range, and it's going to be for the age, which is just this down to this, and we are good. That's our descriptive statistics. And then the next instruction there says, are you going to group it by column or row? By default, we group by column because our data is a wide data, not a long data. It's always arranged in structure, columns and rows. So we allow it to be on columns. The next is your data labeled on the first row? And the answer is yes, because we chose from B1 to D21. So that means our data is labeled as the case may be. Now in this regard, we check the box and say, yes, our data is labeled. Then the next is the output options. What are the output options that we have? Where do you want this result to be? We said that we don't want it to be in a new worksheet. The first is output range. Which range do you want it to be on? The next is new worksheet. Do you want this to open a new worksheet outside the two existing worksheets? New workbook. Do you want it to open a new workbook aside the workbook we are dealing with? So these are the options available for you to see the result or output of the analysis. So we click on output range over here, and then we are going to choose the output range. So the output range you are going to choose here. Oh, you are not seeing it. Like here. Sorry. Let me share entire screen. Oh wow. Sorry, I didn't know you are not seeing it. So let's go back to this again. Sorry about that. I didn't know you are not seeing the screen. You are seeing it now, right? Fine. So on the data tab, we click on data analysis toolpack over here, and we have this data analysis toolpack out for us. We're still going to use this to also run another ANOVA for single factor. So, and also run correlation as well. We must exhaust at least two more analysis of statistics before we hover over to the next agenda on the call. So descriptive statistics is what we are choosing. Remember that we have about 19 statistical tests here. So we choose descriptive statistics and click OK. And the first option is to choose a input range. An input range is the range of data that contains the values you want to run descriptive statistics upon. So we click inside the box to make sure it's actively blinking, and we select the range of data we want. And the range of data we want is from column B1 to D21, just as you can see on the box. But the next is how do you want it to be grouped? This option is very important because sometimes your data can be a wide data or a long data. But because we are doing data analysis with a structured package, which is Excel, our data is grouped by columns, which is a structured data set. And in this regard, it makes Excel a wide data package for analysis. If it's structured in rows, it will now be a long data package, right? But because we have columns and rows, and the data is always understood by the column headers, we say that Excel is a structured analysis tool aside the other reasons that we use it for. So after how you might have selected the columns, although by default it will be there, we now move on to the next option or instruction that says, do you have labels in the first row? Now, what does this mean? It means that whether there is a column headers, right? Whether there is a column headers, you say yes, there are column headers. So we click on the labels in first row is active because we have column headers. So in that regard, we move over to the next instruction. It says, what is your output options? We have about 3 output options. The default one is new worksheet apply. This means that you want it to open in a new worksheet. And by default, Excel might want to create a new worksheet for itself, or you use your hand to choose which worksheet you should load up the data into. Then the last option is the new workbook. You don't want it to be on this particular workbook. You want it to be entirely a new workbook. Then the result will show in a new workbook. But if you want it to be on the same particular worksheet, you need to choose output range, which is the same worksheet you want it to be on. So in this regard, we want it to be on the same worksheet. We choose output range. So here we go and click in the box and choose a particular range you want it to show our results. So let's say our results will be somewhere beside the output of regression. So let's look it here. And it's text or references the cell. Then the next is summary statistics. Remember that we said that summary statistics are those statistics that helps us to understand what happened in our data set. It gives a summary or an overview of our data. And because we are doing statistical analysis, we must ensure that the data sets we are having here are all numeric in nature. So in that regard, we have these in quotes. So we check our summary statistics, which will bring out all the statistics that we might think of under descriptive statistics. I'm not clicking on confidence level for mean because already ANOVA has given us what we are seeing over here from what we saw, but we can still click it if you feel like clicking it. But because we are focusing only on discrete statistics, we only maintain summary statistics. So after we have ticked all these interesting buttons and have chosen the input range and output range, notice the input range is B1 to D21. Output range is one cell of choice, which is I62. And we make sure that we choose labels in first row and our group is in column, while our summary statistics is what we are looking for, and then we click OK. With this, we have the summary statistics for every column in quotes. If we do not click on labels in first row and we just chose all there is, it will notice that it will overlook the first row we have here and take on the remaining values, which means that 21 will not be added in the calculation, 50 will not be added, 88 will not also be added. But because we choose labels in first row, it can add 21, 15, and 88, giving us a total of 20 values. Are you seeing here? We have a total of 20 values in the count. But if we would not choose labels in first row, to give us 19 or 18 values in count, which is going to be very biased in our analysis. So you notice that in age, we have all the summary statistics you can think of. Hours of study with the same thing, but in exam score, we don't have any one. We have all, but we don't have that for mode. This is because the mode is the most occurring number. If you've read your readings for this particular course, you see that all statistical parameters are all explained carefully. The mean, we see that is the average of all the values, and we saw the same value as what we saw over here when we are dealing with the mean of the analysis we are working with. Then the next is the hours of study, the same mean as well from what we have before. Then exam score, the same mean as well for what we have before. Then we now have the standard error, which tells us the difference in variation between the data set around the mean. Similar to standard deviation, we have something as such as well. Then the median is the middle number when the data set is arranged in ascending order, while the mode is the most frequently occurred number in our data set. Then you have the cutoffs and skewness, which helps us to see the dispersion in our data sets. For instance, we say that our data set follows a normal distribution, and if by peradventure this particular dumbbell is unavoidably skewed to the right, so let's see what I mean by that. So this is supposed to actually be in the center, but we have something like this, right? So when we have something like this, we say that this data set has been skewed to the right, meaning that it has moved from being in the normal center line of the line, that's this B, while this is A, as the case may be. So when something like this happens, that it has been skewed to the right, right? It has been skewed to the right. But when it moves the other way around, it has been skewed to the left. So skewness is the dispersion that we get when data set is being moved because of some variabilities that can occur in the analysis. And this is just what we saw here. Some data sets are being skewed either to the left or to the right, while some are already in the center. For instance, this age data is a little bit skewed to the right with just 0.16, while the others are a little bit skewed to the left, just a little, right? Then for the kurtosis, the dispersion that happens around the mean is also negatively impacted in this particular data set. That is what this is showing us. Why the range is telling us the difference between the maximum and the minimum. And as you can see, the maximum value for age is 24, the minimum is 20, and when you subtract them together, you get 4. For hours of study, the maximum is 20, minimum is 4, subtract them, you get 16. The maximum of exam score is 95, minimum is 60, subtract, you get 35. So this is just what we have in the summary statistics. The sum of age is this, sum of hours study, and sum of exam score. And the frequency is at 20. This is what discrete statistics can give you the summary of what you have at your disposal. Now, what if you want to run over straight cut without actually having to find regression over here? We can still do that. Since we have study group and we have exam score, we can actually determine the actual difference between these two variables. What the difference between study group? Is there any mean significant difference between study group and exam score? If there is, how can we determine that? So let's try to use ANOVA straight cut into the data pane. So data pane, data analysis, ANOVA single factor, click OK. So let us take the single factor, which is input range, and see what we have as a result. The labels in first row. Now the alpha, which is the p-value, is at 0.05. Then the output range, we want it to be somewhere beside the existing one we have in descriptive statistics. So let's say somewhere here, and then click OK. Okay, I have a non-numeric value here. Oh wow, sorry. So that bad, I needed to code it. So let's code this guy and see what we have at the end of the day. So let's code group, right? So we are going to code it. Sorry, we've not reached this level, but let me just code it. So if this guy is equal to group, sorry, we are going to come to this end sharp. Is equal to group, we say 1. We say 1. Otherwise, we say 2. So let's have this. So this is the code we have for this. So we copy. Sorry, I'm doing this without telling us how I did it, but we are coming to this guy. So don't panic, okay? Let's come back to data now. What we do is to code these values. So 1 is for group, 2 is for individual, okay? So let's do and see whether there's a significant difference between the group, the study method, and exam score. Come back here again, data pane, data analysis 2, another single factor, click OK. And now I need to actually work on something. I need to hide this guy out of my site. So I'm going to hide this particular individuals. Let me quickly clear the contents. Then I'll also quickly delete this cells. I'm going to shift it to the left. Fine. So I can now do my thing, right? So data analysis, single factor ANOVA. Okay. So my study method is still there for me. So you have this, and output range is still this guy over here. Then click. Remember, we click on labels in first row. Always click on labels in first row if you take the entire data in your range. If you must take all of them, always check labels in first row. Allow your alpha to be at 0.05. That's standard. But if I use 0.01, no problem. So before choosing your alpha, you must know what it means, right? So we click on OK. So it says single factor input range contains non-numeric data. Why is this thing one non-numeric data? Let's see. Okay, this guy should be a number. Let's format it to be a number, please. Let's see. So let's correct this. Let's correct all of them from this error. So you have this. Let's come back again. Data pane, data analysis, another single factor. Click OK. Our range is still there for us. D1 to E21. Output range is still there for us at 062. Then click OK. Fine. So see what we have here. So you see, it has given us a different summary from what we had before. Remember, summary over here in the first one was done with hours of study and exam score, but the second one was done with exam score and study method, right? Exam score and study method. Now notice that there is a difference in this. Notice that you have the p-value, you have the F critical or the critical value, also have the F test, which shows the variability of the data sets. So we see that the difference of this is actually tentative than that of regression, right? So the exam score 2020, the sum is 1611, just as we here. Sum for study method is 30, just as we have, yeah, it's 30 because 1, 2, 1, 2, 1, 2, that's 30. Average 80.55, 1.5. Variance is this and this is that. So between groups, we have this and this. Within group, we have this and this. And these are the values we have. So to conclude our analysis, we see that this is actually less than 0.05, which is our alpha. So we choose our alpha to be 0.05, but the p here is giving us minus 29. Right? So if we have p-value that is significant, that is p-value that is less than 0.05, we say that our analysis is what? Significance. Hence, we need to do what? Reject the null hypothesis and conclude that the exam score is actually affected by the study method. As you can see here, the F critical, that's the F critical here, is 4.0908. Right, F calculated is 999.446. While the p-value is minus 29, showing us that there is an effect of method upon exam score. There's an effect of study method upon exam score. So when people study more in groups, they tend to have more exam score than when they study individually. If you notice again in the data set, you see that those that studied individually are having lesser exam score compared to those who study in groups. Now, see those studying in groups are high exam score. As you can see here, group is for 1, individual is for 2. Group is for 1, individual for 2. So you see that those studying in groups earn high score compared to those studying what? Individually, right? Individual is 2, while group is 1, like we said before. So you see that the analysis we have done here with ANOVA one-way factor shows that it is significant, right? It is significant. So you can reject null hypothesis and conclude that the study groups actually affect the exam score from what we have seen here. You see that the F critical is less than the F calculated, and the p-value we have there is less than our 0.05, which is our alpha that we chose before. And obviously, these 3 parameters have helped us to have a significant conclusion that this study method, called group study method, is very much effective than the individual study method, right? So that's the result of this ANOVA single factor. You can also test out ANOVA two-way factor with replication. You can also test out ANOVA two-way factor without replication. Okay, so let's come back to coding this guy into what it was before. Let us come back to coding what it was. So we say that if this guy is equal to 1, we say is what? Group, otherwise individual. So we have this, and then we copy and paste as value. So we can delete this guy up here, and then reformat it the way you want it to be. So you have the same values as it is. So you see how we have used analysis of statistics to derive the regression, derive good statistics, and also derive single factor for ANOVA, and it have helped us to see. Let us put that conclusion again. So let's put our conclusion so that we can know that we have done justice to this particular results that we have over here. So the null hypothesis will be that the study method does not have an effect on the exam score. Right? That's a null. While the alternate is the study method has an effect on the exam score. Right? Then we have seen that since p-value is less than the regression, okay, let's say since p-value is less than, since p-value and F critical is less than alpha and the F tests, that's F tests, we reject hedge knots, and since the regression value is greater than, okay, we don't need these parts, fine. So since p-value at 0.05, that's the alpha. Okay, since p-value at, sorry, not 0.05, this should be 6.75 exponential minus 29. So since p-value at 6.5 exponential minus 29 and F critical, let's also put the value for F critical 2. F critical at 4.098 is less than alpha, and alpha is at 0.05, and F test is at 999.425. We reject what? Edge knots, and hence we conclude that the study methods affects the exam score. So if you are to make a suggestion now or recommendation to the students, you recommend that they should study more in groups than individually, as the results have shown. And we say that this result is significant, is statistically significant, right? So we are good with what we have so far. So this analysis we are doing is just what we call it, a sneak peek into the more in-depth analysis of statistics we do in data analysis when it comes to research, documentation, expository, health, and finance analysis, even in economical analysis as well. So this we are touching at the basic statistics we do just to help us harness our S-board into what we can think of at the end of the day. So the last of the statistical analysis we are going to look into is the correlation, which tells us the relationship between a particular variable and the other variable. So let's see how that plays a role in analysis. The correlation of the variables. So let's come here. What's the relationship between hours of study and exam score, or age and exam score, or even study method and exam score? So we are going to look into just relationship between the two, the main two, are the hours of study and exam score. To do that, we go to Data tab, pick up our data analysis tools, and we are going to choose correlation over here. Remember, we have a lot of analysis to do in Excel, which you can try out on your own time. We've done regression, we've done ANOVA one single factor. We are now doing correlation. So you might try to, okay, we've also done descriptive, that's 4. So try to explore other statistical functions we have here. which help you to do analysis, so that the t-test, the z-test, and the sampling, likewise the rank and percentile. Also understand that before you do them, you must have studied on what they are, how they are being used, and why we use them. Also understand that you must also know what relevance they are to your analysis, and you cannot do them without having a hypothesis. So you should have a hypothesis you are testing to know whether what you are working on as a project is statistically significant. So the last of them is a correlation, and we are going to click on OK. So I'm changing our input range to correlation. Remember that input range here is always a single value. So Excel sees them as single value, but when you try to run the application results, it sees it as individual values, just you have been seeing so far. So let's run for hours of study and exam score. And always choose labels in first row, because we are choosing from the first row, which is from the row 1 down to the last, so that we don't have an unbiased data at the end of the day. Hence, we are choosing everything, right? So output range, we choose our output range to be somewhere close to ANOVA, or possibly above ANOVA, somewhere here. And then we click OK. So you see the relationship between the hours of study and exam score. So here is correlation. And here is another single factor. So the correlation between these two is very interesting, because as you can see, it's obvious that the relationship between hours of study and the exam score is 0.988. 0.988. So they have strong positive correlation. Correlation tells us the degree of relationship amongst variables. Degrees of relationship among variables. That's what correlation tells us. And we've seen it here. The same result we have over here is likely the same thing we have in the multiple R when we did regression. We said that multiple R is the relationship between what? The data sets. And we see it here playing out again over here, and likewise over here. So what have we discussed so far? So far in statistical analysis, we have seen that we can do different analytical tests in statistics using the data tab as our go-to tab, and the data analysis toolpack as our go-to toolpack for such analysis. We've also seen that the major data analysis we do for statistics when it comes to some data sets are the descriptive statistics, such as the mean, the standard deviation, the mode, the kurtosis, the skewness, the range, the minimum, maximum, the sum, the frequency, the median, and the standard error, outside every other thing. And I've also seen that the other statistical tests we do in analysis, which help us to infer on the data set we have, are regression, hypothesis testing, ANOVA, and correlation. These help us to either measure the degree of relationship between variables, or model the relationship between the variables, and also even do prediction, or find out how much they are related to each other. We've also seen the phases of hypothesis testing, such as the H0 and the H1 that goes with does not, did not, is not, does, did, and is. We've also seen how important it is for us to understand the different type of errors analysts can make when dealing with hypotheses, and how best to reach out to conclusion whenever we are working with any hypothetical test. We've also seen that statistical testing involves us working with numbers more often. When we are trying to work on ANOVA, we saw that we need to code the test variables into numbers so that our analysis can actually run. And when that happened, Excel can take up the values and give us a proper result. So all this we have discussed in statistical analysis is important for you to go through them and get your hands dirty on each and every one of them. We've noticed over here that in this residual that has happened here, this predicted exam score. Let me open it. So we say that regression is used to also predict, right? So we predict the exam scores for these individuals using what we have already gotten as our analysis. And the prediction comes from the y, like we said here, right? The y is the predicted value, which is the dependent variable resting upon the slope and intercept and also the independent variable. So what happens there is that when this is the residual, this is standard residual. So Excel calculates this for us in regards to what it is. If you have thought about machine learning, you notice that most of the machine learning models we build are based on regression because it's a proper model for predicting variables. It helps us to see what happens ahead of time. So I would have gone deeper into this part of residual output, but the only thing you need to know for now is that the predicted exam score was gotten by adding the values for the intercepts B0 with the slope B1 and then multiplying B1 with X1, then adding it together with exponential or the error residual, which is what we do in elementary called BODMAS, bracket of division, addition, bracket of division, multiplication, and what addition. So first of all, Excel, we have to put these two in brackets, right? This B1 and BI and XI in brackets. So B1, sorry, and XI in brackets, and sum them and multiply them, sorry. So when the B1 is the slope from what we have as a result right here, which is what we have as the coefficients. So B1 here is the 2.272, while the intercept, that's B0, is the 52.262. So what will Excel do? Excel will put Y. So let me quickly copy this and show us what Excel does to get this man we have here. So let me paste this. So what Excel will do is this. Excel will come up here and Excel will say yi is equal to 52. Sorry, let me erase this guy. 52 0.262 plus 2.272, right? Multiplied by, what's the xi? So let's say the xi we have here. So the xi we have here is under, that should definitely be under the independent variable, which is hours of study, that's 15. That the first SI there is 15, right? So 15 is the first SI we have. 15 close bracket plus, what's the error residual? So let's come to the error residual. Error residual here we have is 1.6561. So let's work with this. We can still work with this as well. Let's work standard error residual 0.988. Since we are dealing with normal standardized data, 0.988. So 0.988. So when Excel runs this, it gives us the first YI, which is what we have here as 86.3438, which is the first value for the exam score. So if someone should study for 15 hours, right, which is the first independent variable, the person is predicted to have a score of 86. And over here, the actual is what? 88. So it's not too far from the actual score. Now, if someone studies, this one is for in the group study, because you notice the method is group. Now, if someone studies for 10 hours individual, what's the predicted exam score? Here is 74.983, with approximately 75, just also we see here. So you see, you can actually do prediction with regression using what we have just showed us here. So if you should run this analysis, you multiply 2, 7. So let's try to do it and see if we get it. So let me search for calculator. I just want us to show us how sweet regression can be, or even statistical analysis can be, when we know how to do it very well. So let's try doing this scientific, right? 52.262 plus open brackets 2.272 multiplied by 15 close brackets plus 0.988. Do you see we have 87.33 as a value here? What do we have here? Are you seeing it here? It's 6.34. So this is because I didn't even add other value. I just took the 33 digits, and the value we have as a response is what is 7.33, which is close to what we also, very close to what we also have here. So very sweet. That's what regression is all about. And even analysis of variance, correlation, and every other statistical analysis you can always think of. So I will encourage you to please explore more about this statistical analysis we have done so far. Notice how each and every one of them plays a role in your life as an analyst who should understand statistics in order to become a good fit for what he is doing. So we say that the result of this is what is 7.8, it's 7.33. That's exactly what we even have. Because it's 7.33. That's our final answer. Now, that's because I'm working with two decimal places. We didn't take every value. Remember, we didn't take all the values in this. Neither did we take all the values in this, or all the values in this mass, sorry, here. So that's how sweet it can never be. So let me just highlight what we used here. So in case you watch the video, you can remember the one we used for the statistical test. So this one was a B naught. B naught is red, sorry, is orange, while B1 is red. Then the other residual, I'll color it green. Right, so this was the error residual we use as E. Let me still draw something on it. Now, helping you so that when you have seen the video, you know the one that we use for the practice. So you can actually experiment it for yourself. Why we use this guy as our B1. Then we use this guy as our B0. So let me just leave it here. Fine. So that settles it. So you can explore to see whether Excel is actually correct by the predictions it has here, and see how close they are related to the actual exam score that the students actually have. So thank you very much for today's class. I really appreciate your tenacity and how you have been doing well in submitting your assignments, and also being very good and lenient in filling up every class schedule as it is. So we are still going to have our class tomorrow, and we're still also going to have a class on Friday. This is because we have a hiccup yesterday when our network wanted to finish our live, but thanks to God that didn't finish our live. So by tomorrow, we are going to hover into the next agenda on our call, which is exactly on functions and formulas in Excel. So with the knowledge we have now, we can definitely utilize Excel functions and formulas, which also shows into advanced Excel part 1, data prepping, and the rest of them. So I really appreciate if you have any question, kindly unmute and ask so we can track them down.
Good evening, sir.
Good evening.
Okay, my question is this pattern that we follow, this statistical analysis pattern. I understand that in most data you are going to encounter this is like the go-to. You understand? But from what I used to see online, the stakeholders usually like give you different questions like you need to tackle with this data set. So I want to know. My question is if this pattern now that we follow now to deal with this data set now that you presented now, is it like a go-to pattern, like is a primary, like is a foundation for any other question you want to answer? So for every data set you encounter, you must do something like this and then keep it by the side before you can now start doing the other secondary and the tertiary analysis.
Okay, I understand your question. Thank you for that. So Remember that what we are doing is learning, and in every learning phase, there's always a step on the way. So, analytical question that comes your way might not require you to do statistical analysis on it, but it might require you to use your analytical thinking as a data analyst to solve the problem. What it means is that I might have question A, and question A will only be on some certain questions of choice that is not even in relation to statistical analysis. So when that happens, what do I do? Will I say because my stakeholder asked me question in statistics, in data, I will now go and answer the question without even understanding what I'm meant to do? So the main aim is for us to actually understand the objective of the study. We understand that it will now be easy for us to know whether we are to use statistical tests to run it or just flow with our usual data analytics workflow. Because your workflow as a data analyst is different from your workflow when you are trying to embed statistical thinking into it. For instance, you have a school project. That school project definitely will require you to use statistical tests for it because it is what the academics use. Academics are very good at using statistical tests. Or maybe you have sales project. Now, sales project does not require you to even use statistical thinking in it. But when it's not required to use statistical thinking is when you're writing your report. Now, that report is now where you tell your stakeholder the reason why XYZ is equal to 1,000 or why ABC is equal to minus 200. Do you get? That's when you talk about dependencies, the correlation, the causation that makes such thing to happen. That's when you are doing your exploratory data analysis. But for a normal workflow of a data analyst, maybe a business analyst, a sales analyst, you don't run statistical analysis inside of it. Rather, those analysis you want to run will now come in your report, where you give reasons why XYZ is equal to ABC, not actually doing what we just did here. What we just did here is to help you to see the value of statistical analysis in data analysis. You will see that when you continue growing in this our learning, you see where we are trying to bring in statistics into our learning because it must come. It must come, but it doesn't mean that you will have to start doing descriptives, start doing ANOVA, start doing regression. No, it's only when the objective calls for it, you will do it. But when the objective does not call for it, do your normal workflow, solve your objective questions, and you are good to go.
Okay, sir. Thank you very much, sir.
All right. So thank you very much. I really appreciate that question. It's really interesting to go through it. So see you tomorrow and see others tomorrow as well. Have a wonderful night rest.
Okay, sir. You too, sir.